Okay, this lesson video follows our factoring lesson, and this would be done on a gold paper if you were in class with me, and it's a factoring guide, which is nice, this factoring guide, because we're going to do it on our gold paper. That means you guys could use this as a reference when we take our Unit 5 test. So it kind of just goes over all the different types of factoring and kind of when they can be applied. A lot has to do with how many terms are in the polynomial you were asked to factor. Now this really big important part, okay, up here it says check for a GCF first. Okay, that's something you should always do. When you're looking at a polynomial, no matter how many terms are in it, think, is there anything they have in common that can be divided out? So that's just going to be our first look through when we're doing it. And then it might be a different type of factoring. So we're going to start with things that have two terms. And I'm going to kind of zoom in here. So for two terms, the first thing maybe it could be is difference of squares factoring. And we have a rule for factoring difference of squares. Again, two perfect squares with a minus sign in between. We always make two sets of parentheses. One has a plus, one has a minus. And factoring undoes the polynomial. So what undoes squares is square roots. So square root of a squared is a. We put that first in each. The square root of b squared is b. So we factor them in like the formula or the pattern of a plus b times a minus b. So you'll notice there's not any examples written in. We are going to fill them in ourselves. So let's do this one. If we had x squared minus 9, okay, those are two perfect squares with a minus sign in between. How could they be factored? We would make two sets of parentheses. One gets a plus, one's a minus. I break this apart. The square root of x squared is x, so we put that first in each. The square root of 9 is 3, so that goes second in each. So x squared minus 9 factors to x plus 3 and x minus 3. Okay, let's do another example. Let's say we have 16 x to the fourth minus 25. Okay, so look, even though we have a number in front, okay, as a leading coefficient, it's 16 is still a perfect square. X to the fourth is a perfect square because even though it's not squared, it has an even exponent, and so is 25. So factoring this, again, just always start off by making two sets of parentheses. One gets a plus, one gets a minus. The square root of my first term, again, this is all going to stay together, the whole square root, 4x squared. And that goes first in each set, 4x squared. The square root of 25 is 5, so it goes second. So this factored out is 4x squared plus 5 times 4x squared minus 5. And then we have, let's do one more example. Let's put in 48x squared minus 3. Okay, so sometimes we're like, man, we got two terms. Okay, got a minus sign in between, something squared, but 48 and 3 are not perfect squares. So remember, we had our rule. Check for a greatest common factor first. So I'm looking at 48 and 3, and I'm like, oh, hey, 3 goes into 48. Okay, so 3 is our GCF. It can be divided out of each term. So we're going to have 3 parentheses. 48 divided by 3 is 16. And then we still have x squared. Negative 3 divided by 3 is negative 1. Okay, so we took out a GCF, but we're not finished yet because inside this part, we have our two perfect squares with a minus sign in between. We factor it again. So 3 stays on the outside, and then two sets of parentheses. One's plus, one's minus. The square root of 16x squared is 4x. And the square root of 1 is 1. So it factors out to be 3, then 4x plus 1, 4x minus 1. Okay, another type of factoring that can be done if we have two terms is sum of cubes. Okay, so we just learned this in our last lesson, and it's not going away. Sum of cubes is factored, okay, if you have two perfect cubes with a plus sign in between. Again, that's where the word sum comes from. It's factored by like a formula, basically. It comes out to be a plus b times a squared minus our a value times our b value, so ab plus our b value squared. So that means your first step is to find out what the a and the b values are, which is the cube root of the two terms we start with. So let's pick a few examples. let's say we have x cubed plus 27. Again, x is obviously a perfect cubed because it's raised to the third power. 27 is a perfect cubed. And I'll probably have you, if you're in class, make a note card that has like a list of perfect squareds, perfect cubes, and we'll even get to where we use perfect fourth powers. Woohoo! So I'm going to say the cube root of x cubed is x. So a is equal to x. The cube root of 27 is 3. So our b value is 3. And now we'll plug them into this pattern for factoring. So a plus b will be x plus 3. Then we have our a value squared, so that's x squared. Minus sign, again, the signs always have to be exactly as they are for this type of factoring. So minus 3 times x is 3x. Plus sign again, our b value squared is 3 squared, 9. And remember, for sum and difference of cubes, you never have to look for an extra type of factoring. It's always done, which is really nice. Okay, now let's move on. Let's do another example. How about 8x to the 6th power plus 1. Okay, so again, our exponents are perfect cubes if they are multiples of 3. 3, 6, 9, 12, and so on. So here, if I cube root 8x to the 6th power, the cube root of 8 is 2, and the cube root of x to the 6th is x squared. You always just divide your exponent by whatever power you're undoing, so by 3 in this case. Our b value, the cube root of 1, is 1. So a is 2x squared, b is 1. And now we fill it in. Excuse me. So a plus b will be 2x squared plus 1. A squared is, again, we're not just squaring the end of this. A squared means 2x squared times its own self. So 2 times 2 is 4. X squared times x squared is x to the 4th. And then minus a times b, 2x squared times 1 is 2x squared. And b squared is 1, so plus 1. And now it's done. One more example. Let's try 216 x cubed plus 125 y cubed. Okay, we've just added a little bit bigger numbers and some bigger terms. But again, start by finding your a and your b. The cube root of 216x cubed, okay, use your calculator if you don't know, would be 6x. The cube root of 125y cubed is 5y. So those numbers are getting substituted for the a's and b's in our factoring formula. So a plus b will be 6x plus 5y. A squared, again, 6x times its own self. 6x is 36x squared. Minus a times b, 6x times 5y is 30xy. And then plus sign, our b value squared is 5y times 5y, 25y squared. Okay, hopefully you can see that, but that one's done now. Okay, and then if it's two terms, it could be difference of cubes. Again, it's still two perfect cubes, but now we've got this minus sign in between, which is almost identically factored like sum of cubes, except we change where the minus sign is at. Okay, because the minus sign is in between our first two terms, for factoring, it is a minus b first. And then it is a squared plus a times b plus b squared. So just make sure you're getting used to where that minus sign is. For difference of cubes, we use that minus sign first. So the first example we're going to try is going to be 64 minus x cubed. So I'll label my a and my b still, just like I did before. A is the cube root of my first term. The cube root of 64 is 4. The cube root of x cubed is x. So a is 4 and b is x, and now we fill them into this formula. A minus b will be 4 minus x, and it kind of feels like that's out of order, but remember, you stay in the order of the original problem. My 64 was first, x cubed was second, so we keep that order. Parentheses, our a value squared, 4 squared is 16, plus sign, because of the formula, 4 times x is 4x, plus sign, our b value squared is x squared, and it's done. Very nice. Okay, another example we will do is 27x cubed minus 8. Okay, these are two perfect cubes, minus sign in between. Let's undo these cubes by cube rooting. The cube root of 27x cubed is 3x. The cube root of 8 is 2. So we start off with a minus b. That will be 3x minus 2. Then it's our a value squared. 3x times 3x is 9x squared. Plus a times b. 3x times 2 is 6x. Plus our b value squared, 2 squared is 4. And it's finished. Okay. One last example for this section. We're going to do 512x cubed minus 8. Now sometimes it feels a little sneaky. 512 and 8 are both cubes, but they still also have a greatest common factor. So if you ever notice, and you have to be on the lookout, that there is a GCF, you have to divide it out no matter what. So 8 goes into both of these. We're taking it out as a GCF first before we label our A and our B. So we have 8, and if we divide these both by 8, it would be 64x cubed minus 1. Okay, and now we'll label our A's and our B's. So A is the number that's first in here. So A will be the cube root of 64x cubed, which is, let's see, the cube root of 64 is 4. And then it's also x. Okay, for B, the cube root of 1 is 1. And now we'll use our formula, but this GCF of 8 will be on the outside. So it's 8 parentheses A minus B, 4x minus 1. And then our A value squared is 4x times 4x for 16x squared, plus sign A times B is 4x, plus sign B squared, 1 times 1 is 1. And now it's done. So just always be on the lookout for that GCF. Okay, if there are 3 terms in your polynomial, that's called a trinomial. And remember, we kind of label this as 1, 2, 3 factor tree. That's kind of our little saying in class. Okay, so let's do it where our A value is equal to 1, meaning not a slider. And you guys should all know what I mean by slider. So we'll do a couple examples. If we have the trinomial x squared minus 6x plus 5, and we need to factor this, we would do 1, 2, 3 factor tree. What multiplies to 5 but subtracts to negative 6? And that would be negative 5 and negative 1. So in factored form, it would look like x minus 5 times x minus 1. And that would be done. Another example could be like 3x squared plus 3x minus 60. Okay, now I do have looks like a leading coefficient, but I do not need to slide it. 3 can come out as a greatest common factor. It goes into 3, 3, and 60. So when we divide it out, we have 3, then parentheses, x squared plus 1x minus 20. And now that we've gotten rid of the number in front of x squared, we can do 1, 2, 3 factor tree. What multiplies to negative 20 and subtracts to positive 1 would be 5 and negative 4. So in factored form, this would look like 3 times x plus 5 times x minus 4. And it's done. Okay, if we have 3 terms, but we have an A value that is greater than 1, that means a number in front of x squared that does not divide out. Okay, we call these in class sliders. Or we could say slide. We have to slide, divide, and then bottoms up. That should be an M. All right. So let's see. Let's start with the example 2x squared plus 15x minus 77. Okay, so I'm looking and I want to do 1, 2, 3 factor tree, but 2 does not go into 15 and 77. I have to get rid of it so I can factor. So we're going to take this front number 2 and slide and multiply it to negative 77. So we have x squared plus 15x minus 77 times 2 is negative 154. Okay, now we do our 1, 2, 3 factor tree. What multiplies to negative 154 and subtracts to 15 will be 22 minus 7. So we write it as 2 factors, x plus 22, x minus 7. So that was our slide in our factoring, but now we have to divide. We divide by the slider. So we divide each of these two factors by 2. And then we simplify. 22 divided by 2 is 11. So this factor is x plus 11 now. 7 does not divide by 2. And again, we're not getting solutions. We're not t-barring this. We're leaving it in parentheses. So we have to go bottoms up. So this is 2x minus 7. And now it's fully factored. Okay, another example. Let's just do one more. Let's say we have 6x squared, my pins, minus 13x minus 28. Now again, I'm looking for a greatest common factor, but there's no number that goes into 6, 13, and 28. So we'll remove our 6 by sliding and multiplying it to negative 28. Okay, so now we have x squared minus 13x minus 168. So now we can do our 1, 2, 3 factor tree. So we're looking for two numbers that multiply to negative 168 and subtract to negative 13. Okay, you might have to use your calculators a little bit on your own if we're dealing with some bigger factors like that, but it will be positive 8 and negative 21. So we write it as x plus 8, x minus 21, and then we divide by our slider. Our slider was 6. Okay, now neither 8 nor 21 divide evenly by 6, but they can still simplify as fractions. So we need to do that before we do bottoms up. 8 over 6 is 4/3. 21 over 6, they both divide by 3. We would get 7/2. Okay, now we still have fractions, so we still have to go bottoms up. 3 is on bottom. It comes up in front of x to give us 3x plus 4. The 2 is on bottom. It goes up in front of x to give us 2x minus 7. And now that one's done. Okay, if we have 4 terms, we try factoring by grouping. So that's when we split them, our 4 terms into 2 groups of 2 terms each and take out a GCF of each group. So for our example, we will start with x cubed minus 2x squared plus 6x minus 12. So my first step is to cut it in half. And I'm going to look at my first grouping and what goes into x cubed and negative 2x squared. The most we can take out of that they have in common is x squared. So I'm going to kind of go underneath here a little bit. But if we have an x cubed and we take out an x squared, we're left with 1x. Negative 2x squared, take out the x squared is negative 2. Wrap it up, but put the GCF on the outside. My next grouping is 6x minus 12. Its GCF is 6. So 6x divided by 6 is x. Negative 12 divided by 6 is negative 2. And this is a positive 6, so we put plus 6 on the outside. Now to finish, we check what's in our parentheses. They match exactly. It's not x minus 2 squared. It just meant we did it right, and it's in our answer once. Then my 2 GCFs of x squared plus 6, they make their own factor or their own binomial. So this is x squared plus 6, x minus 2. And I notice I have something squared still, but there's a plus sign. So I can't do difference of squares. So that's done. And one more example. Okay, let's write it down over here. Okay, we will do x cubed plus x squared minus 9x minus 9. Start by cutting it in half. Looking for a GCF in my first group, x cubed and x squared, we can take out 2 x's, x squared. When I take 2 x's out of each, I'm left with 1x plus 1, and then put x squared on the outside. My second grouping of negative 9x minus 9, because my first term in this grouping is negative, I make my GCF negative. If I divide each of these factors or terms by negative 9, I get positive 1x plus 1. I wrap it up and put negative 9 on the outside. So I have 2x plus 1. If you forgot to divide by a negative 9 up here, our 2 sets of parentheses wouldn't match, and you would have needed to recognize that and then adjust. But we have x plus 1 time in our answer, and our 2 GCFs, they hook up, x squared minus 9. I always look back at my x squared term right here, because it's x squared, maybe it could be factored again. Okay, anytime it's squared, maybe. I have a 9, which is also a perfect square, and a minus sign in between. So we can do difference of squares extra to this one. So 2 sets of parentheses, one's plus, one's minus. The square root of x squared is x. The square root of 9 is 3. So that x squared minus 9 could be further factored to x plus 3, x minus 3, and then bring down your x plus 1. And now it's done.